Okay, so good morning, everyone. So we are going to continue with chapter 17. We have learned chapter 17 last Wednesday, and hopefully that has helped you doing the lab on capacitors. So it was about the charging and discharging, right? Which we have covered in class. I don't know why I'm stuttering. Okay, give me some time. For today, let's do a little recap, and then we are going to learn the last subtopic for this chapter, which is on capacitors in series and capacitors in parallel. So, in series and parallel ni penting meaning to say, I don't know if you guys have learned this in high school, but series and parallel is related to electric circuits. So knowing what a series mean, what parallel means is very important so that you can bring that knowledge to the next chapter. I know everything macam related, right? But that is life. Okay, I'm gonna do the recap. And I'm not sure why, kenapa saya gagap-gagap hari ni. Hopefully that will disappear soon. So what have we learned so far? We have learned about capacitors, and capacitors has the equation of C, capacitance, which is in farad, right? And the equation is equal to Q over delta V, or in this case, we just say it's a V. Delta V or V is a potential difference across the two plates. Okay, we have two plates. That's a capacitor. It has to have two metal plates that is connected to a battery or is connected to a resistor or a bulb. Okay, so it depends on whether it is charging or discharging. Okay, so if it is charging, it will be connected to a battery. And if it is discharging, it is connected to a resistor or a bulb, anything that is able to conduct electricity. The difference in voltage between these two plates is the difference in potential between the two plates is our delta V, or just V. And it is equal to the battery that we supply it with. For example, I have a battery of 5 volt. Therefore, the potential difference between these two plates will also be 5 volts. So this is going to be 5 volts. Okay. And I need to know, I need to assume one plate will become high potential, the other plate will become low potential, and the one that is connected to the positive side will have the high potential. The one that is connected to the negative side of the battery will have the negative potential. Okay, another equation that we have learned about capacitors is fancy K epsilon naught area over distance. What distance? This is the distance. D. What area? The area of the plates. Okay, that's the area of the plates. Epsilon naught is a constant, 8.85 times 10 to the something, I don't remember. And fancy K is when you have a dielectric. If you want to keep this equation as it is, yes, you can do it. When your capacitance has air in between them, you can keep this equation like that, but your K will be equal to 1 when it is in air or vacuum. Boleh, you can keep the equation like this, but you have to know that for vacuum and air, the fancy K is equal to 1. For dielectrics other than vacuum and air, it should be greater than 1. When we have a dielectric with a fancy K of greater than 1, our capacitance will increase. Okay? Our capacitance will increase, which means that if we put in a dielectric other than air or vacuum, we are actually improving the performance of the capacitor. So that is very interesting. And the dielectric must be insulative. Okay, it cannot be conductive. We have metal plates for the capacitor punya plates. So lah, in between the metal plates, it should be something insulative. Air is not really conductive, so boleh lah kan. So dielectric should be insulative. Now, how do you increase the performance of your capacitor other than having a dielectric? Is by increasing your area or by decreasing your distance between the plates. So the closer your plates are together, the greater your capacitance. Okay. What else? This is in coulomb. This is in voltage. This is in F, so don't get that confused. And okay, we have another one. The energy stored in a capacitor, if I'm not mistaken. Let's see. Is that the word? 1/2 Q squared over C. Hello, where is it? I forgot. I forgot where it is. It is before charging and discharging. Okay, it should be around here. Okay, it's here. Okay. So this is the energy stored in a capacitor. Okay, energy stored in a capacitor. So that is the keyword here. So let's continue with our recap. Okay, so energy stored in a capacitor. Let me use a different color. So energy. So A. Hello. Cooperate with me, please. Okay, so energy stored in the capacitor, okay, is equal to, energy is in joules, you know this already, dah beribu kali cerita pasal ni. So it should be equal to 1/2 Q squared over C. This is also known as the PE, potential electric energy, electric potential energy of the capacitor. So Q is the charge, C is the capacitance, and if you want to have another version of this equation, you can substitute C equals to Q over V, depending on what you want to eliminate. Contohnya, if you want to eliminate C, then you substitute C, Q over CV, Q over V in this C. If you want to eliminate Q, then rearrange this to solve for Q, CV. So substitute Q with CV squared. Substitute Q with CV. So you will get C squared V squared over C. Okay, so depending on what you want to eliminate, depending on the question lah. Jangan pandai eliminate sesuka hati and then tak boleh jawab soalan. Okay, you have to look at the question. Okay, what else? We talked about all the equations so far. The charging and discharging. Okay. I don't know how helpful having a recap with you guys, but I'm going to do it anyways. So we have two situations, charging and discharging. Okay, tak tahulah korang ingat lagi ke tak, baru belajar ni. So charging and discharging. So we have two different equations. They do not have the same equation. Charging means you start from neutral and you go to fully charged. So this is what charging means, right? Like, obviously. So discharging is you go from fully charged to neutral. Okay, what are you charging? You're charging the capacitor. Of course, we're talking about capacitors here. So if I start with neutral, I should start from a 0 to fully charged is a Q, right? If I start with fully charged, I should start with a Q to a 0. So my graph should represent this. So let's try to remember how to draw the graph. So this graph should be, tak ingat, over time. And this is the amount of charge that is stored in the capacitor. So if I start from a neutral to a fully charged, so I will end at Q. Q is a value, Q is a value. This is charge in coulombs, okay? So Q is the maximum charge that your capacitor can store. Okay, so if I start from a 0 and I end up at Q, my graph looks like this. Okay, dia increase, tapi over time that increase becomes slower and slower. Okay, dia, I don't know what the term is mathematically for that, but the gradient is like this. The increase becomes slower over time. And there is an important information that you need to know about charging, which is related to the time constant. Time constant is equal to RC. So at time equals to the constant, at time equals to RC, depends on what your RC is. Let's say your RC is equal to 10 seconds. So at 10 seconds, you should know that the charge in your capacitor has reached 0.63 of the maximum charge that it can store, or 63% of the charge that it can store. So you achieve that at the time equals to the time constant. Okay, time constant is just a value in seconds. Okay, if I write tau there, it just means a value that is equal to the time constant. So whatever your time constant is, it can be 5 seconds, it can be 15 seconds, it can be 10 seconds. So that is the time when your capacitor reaches 0.63 of the maximum charge that it can hold. Okay, so if your charge can hold 10, no, let's say 100. If your capacitor can hold 100 charges maximum, this is Q, Q max is 100 charges, contoh. Then at time equals to the time constant, or time equals to RC, your capacitor has 0.63 of the maximum, which is in this case 63 charges. Okay, it's just a ratio, or it's just a percentage. Okay, but this percentage is very, very important. All right, so time constant is related to that. So the time constant for discharging is also equal to RC, but it's different. Remember, we start from a Q and we go down to a 0. So if I were to draw the graph, it would look like this. So this is time, this is Q, and I start from a maximum Q because I am discharging, right? I'm discharging, so I start from a Q. I need to end up to 0. So this is how my graph looks like. And at time tau equals to, at time t equals to tau, or at the time constant, my capacitor should have 0.37, I think. 37 of the maximum charge that it can take. So if my capacitor has a maximum charge of 100 charges, so at the time constant, when I am discharging the capacitor, I will have 37 charges left. Okay. So I think this is okay so far. Any questions about what we have learned so far? Anything that is confusing? Or is everyone okay? I need feedback. So,
Okay. Okay, doctor.
okay, Je. So no question,
Okay, doctor.
nothing weird to ask, nothing confusing. Okay, so everyone understands this subtopic,
Okay.
Alright.
Doktor. Kalau yang untuk E-efficiency bila kita nak pakai?
Oh, the E-induced, right? Okay, forgot about that one. Soalan macam tu kejap. Saya tak tengok lagi soalan web assign, but if I were to kalau saya cuba ingat my previous semesters that I taught capacitors, you would use the E effective when you want to calculate for the fancy K, because remember your fancy K can be calculated by C over C naught, or E effective over, I'm sorry, it was E naught over E effective. So if they give you these values, E naught, which is the initial electric charge, the initial electric field before we put in a dielectric, And E effective is after you put in the dielectric, which is E naught minus E induced. Okay, if you guys still remember, E induced is the electric field inside the dielectric. So should I repeat that part or is that okay? So you have two plates, okay? So this is your E, this is positive, this is negative. Your electric field starts from a positive, so this is your direction of E. This is your E naught, okay? This is your E naught. And then when I put in a dielectric, this is the same metal plate. I put in a dielectric, let's use pink, dielectric over here. So there will be a different electric field induced within the dielectric material. So previously I had this going from left to right, right? Left to right. So now, because of this, this is positive, so this will be negative. This is negative, this will be positive. Remember, they will be like reorienting, is that the right word? Themselves according to what they are attracted to. So if this is a positive, the sides with negative charges will menghadap the positive. The sides with the positive will menghadap the negative. Dorang pusing-pusing je, dorang. This is in solid. So solid boleh apa? Boleh pusing-pusing je lah kan, dia tak boleh move about. So they can only reorient themselves in a way that their atoms punya sides, this is negative and this is positive. This is positive, this is negative. That's all that they can do. So with that said, when we have a negative, kita lebih berat ke negatif on the left side and kita lebih positif on the right side, we will actually induce another electric field. Okay, so that is from positive to negative. So this is your E induced. And remember, you have E naught, which goes from here to here. That is your E naught. Okay, so E effective is simply your E naught minus E induced. When is this important? When you want to find fancy K, they give you the value for E induced, they give you the value for E naught. So you have to find out what is your fancy K, which is E naught over E effective. Okay, it can happen vice versa. Maybe they can ask you to explain how the dielectric, how E effective is produced. Maybe, okay, I don't know. I have not seen the questions yet, but I think this is okay. Pretty easy, right? Good. I don't know, but it looks easy to me compared to chapter 16, chapter 15. This chapter is like way easy. So please try to score this chapter. Okay. So that is that. Okay, so let's continue with our next subtopic. If you don't have any other questions, are there any other questions? Tak ada, eh? Okay, so everyone's okay. All right. Okay, so in this subtopic, this is our final subtopic. Yay! We are going to know what is equivalent capacitance. We are going to learn what is series. We are going to learn what is parallel. And then we are going to calculate the charge and the voltage of the capacitors in series and parallel. But of course, you need to understand what is equivalent and what is series and what is parallel for you to be able to do the second point. All right, so let's move on. I don't like a lot of words. Let's just copy the diagram first. Okay. So let's take a look at this diagram. Okay. So let's take a look at this diagram. Previously, we talked about one capacitor connected to a battery. So now we have two capacitors. So how does it change? So let me tell you, when you have a capacitor that is connected in one line, just bear with me first. When you have capacitors that are connected in one line, one wire, they are called in series. Okay, What does it mean when you are connecting it with one line? If let's say this is wire tau, ni wire tau, electric wire. So let's say your electric wire is actually a pipe. Pipe tu apa? Pipe je lah, pipe. Okay. So I put in water inside the pipe. And I have a capacitor over here. And I have another pipe over here. And I have a capacitor over here. Anggap capacitor tu berlubang lah. Okay. Kita nak cerita analogy dulu. So my capacitors are connected in pipes. Okay. So if I were to put in water inside the pipes, my capacitor will how do you say? My capacitor will bertemu, will meet the water. This sounds wrong, but okay. But the capacitor will meet the water. This is C1, right? Will meet the water, and capacitor 2 will meet the same water. Maksudnya kalau water ni orang, C1 ni jumpa orang yang sama, C2 pun jumpa orang yang sama. So this is what it means when they are in series. They meet the same person. So if I have an electric, what do you call it? Current. If I have current flowing, current ni kita anggap macam water. If I have current flowing and it is called I1, C1 will meet I1. C2 will also meet I1, not his twin, but I1. Not a fraction of I1, but he will meet I1 as a full person. Okay, so that is what it means to be in series. So if there is current flowing through C1 and that current is called I1, C2 will also meet I1. Okay, so that is series. Okay, so that is current. Kalau current, dia akan jumpa orang yang sama. So what about voltage? C1 and C2 will not have the same voltage, but they will have V1 and they will have V2. V1 and V2 are not the same if C1 and C2 are not equal. Okay, bear with me first. V1 and V2 are not the same if C1 and C2 are not equal. But V1 plus V2 must be equal to this V battery. What is V battery? V battery is actually V total. Okay, this is for series. So let me repeat myself. For a series circuit. Okay, for a series circuit, I or current I flowing is the same. Okay, we have seen this. C1 jumpa I1, C2 also meets I1 or just I. Okay, I1 is just a name. And for a series circuit, the voltage of the capacitors should be equal to the total voltage. Or V battery. Okay, so that is for a series circuit. So I should be the same. V is the sum. V1 plus V2 it should be equal to V total. Okay. So that is series. Kejap, let me see if there is a parallel. Okay, parallel ada. Tengok tu, degil betul benda ni. Okay. Wow, tu besar pula. Is everyone okay so far about series? Okay, kalau soalan tanya je tau. I don't mind you interrupting. Okay, so this is called a parallel circuit. Okay, so they are. So tadi we have seen in series whereby the capacitors are connected with a single wire. So if saya letak air tu mencurah dekat pipe yang sama. Okay, so now let's say I have water flowing, okay, from the battery. So this water is 100 milliliter. Okay, water cakap pasal water dulu. So I flow, anggap the wires are made out of pipes and I am putting 100 milliliter of water. Now when it goes to this point, dia akan berpecah. The water will be divided. Let's say it divides into 70 ml here and it divides into 30 ml over here. So with that said, C1 is not meeting the same I as C2. Okay, I'm going to repeat myself. I put in 100 milliliter of water. When I reach this point, dia ada cabang kan? Ada cabang, which means that my water will be divided. Tak tahu macam mana dia divide. It can be 50-50 or it can be 70-30. Tak tahu lagi macam mana. But it will be divided, which means that C1 will see I1, C2 will see I2. They will not meet the same I because the amount of water flowing through the capacitor is not the same. Sebab I itu dah berpecah. Okay. So now this 70 ml continues flowing down here. This 30 ml continues flowing through here and they recombine to make 100 ml of water again. Okay, so based on this concept, I can say I1, I2. So I1 plus I2 should be equal to I total. Betul tak? So this dude supplies me with I total. So I1 plus I2 is equal to I total. Now this is about current. What about the voltage? What about the voltage, right? So this is I total, this should be I1, and this should be I2. Okay. You can imagine current like energy cannot be created or destroyed. If you have I total, you will end up with I total. Tak ada I total plus I1, tak ada. I total is the maximum that you can have. So it can be divided into many I's, but in the end, they will all recombine to become I total. This is a simple circuit. If you take EE or mechanical or engineering engineering in general, you will see benda ni in more complex circuits. But this is just the intro. Okay, so I1 plus I2 is equal to I total. What about the voltage, right? So voltage, let's use a different color. I like pink, so let's go with pink. So V for parallel, previously kita tengok, this was V1, this was V2 for a series, right? So what is V1 and V2? V1 plus V2 should be equal to V total. For a parallel circuit, the V is equal. So if this is V battery and the value is 10, this is also V battery. This is also V battery. So capacitors that are in parallel with the battery, okay, capacitors that are in parallel with the battery will have the same voltage. Yang ni tak parallel. This is in series. Parallel ni bermaksud there, if I were to redraw this, I can say no, this is not a good diagram. Kejap how do I say this? Okay. They are connected with the same point. Okay, that is the right word. Okay, so look at this pink dots. Okay, this pink dot, this pink dot, and this pink dot. I can say the pink dots are equal. because there is nothing in between these pink dots except a wire. So I can actually say, okay, capacitor dia macam ni. This is my single dot. This is my battery. So actually these three dots are a single dot because there is nothing in between these pink dots, which means that they are actually the same point. Okay, so this is what it means to be in parallel. They are connected by the same point. Okay, let me repeat myself. Parallel means they are connected by the same point. Okay, how is this different to series? Now, if you see, kita guna analogy dot ni lagi eh. So if I were to say, if I want to say this guy is in parallel, so I need to say they are connected by the same dot, right? Okay, let's see. Is capacitor number 1 connected by the same dot on both sides? No, it's only connected to this dot over here, and this part over here is not connected to the same dot as the battery. So I cannot say it is parallel to the battery. What about V2? Sorry, what about C2? This is C2 eh? C2 is connected to one dot, but the other side of the capacitor is not connected to this dot, which means that the capacitor number 2 is not in parallel with the battery. Okay, for parallel, we need the components need to be connected with the two dots. Okay, dot kat sini, kena sama dengan dot kat sini, dot kat sini, dot kat sini, dot kat sini for it to be in parallel. Okay, let me summarize in parallel, just like what we have done for in series. So in parallel circuit, okay, voltage is the same. Okay, so C2 has V battery or V total. C1 also has V battery or V total. I is not the same. Okay, assuming that the capacitors are not equal. Okay. So is everyone okay with the concept of series and parallel so far? Any burning questions? Or is everyone asleep? Jangan tidur please. This will build your knowledge for the next chapter. Okay, is
Ada lagi chapter.
apa? Sorry, tak dengar.
Kita orang tak tidur, Doktor. It's okay, we're here.
Okay. That's good. Okay, tak ada soalan eh? Alright, so I'm going to move on to equivalent. So kita telah cakap pasal series, we talked about parallel. Now I'm going to talk about what is equivalent. Equivalent eh? And as usual, I don't like lengthy words. So new slide. What does it mean to be equivalent? And in this chapter, we are talking about equivalent capacitance. Okay. Equivalent capacitance. In later chapters, not this chapter, we will talk about equivalent resistance. So you need to know what is equivalent lah sebenarnya. So equivalent means kejap. Is there a good analogy to see? Okay, so let's use this diagram lah. Okay, so previously we talked about capacitors in series, right? Let me redraw the capacitors in series. So it was like this. Okay, so it was like that. And this is C1, this is C2. And then we also had capacitors in parallel. So this is C1, C2, and then we had the battery. Okay, saya draw balik so that you guys can try to relate. This does not look good. Okay, this is my battery, so that you guys don't get confused. So this is my battery. So the pink guy is the battery, the blue guy is your capacitor. So this is in parallel and this is in series. So I can ask you, okay, for this series circuit, what is the equivalent capacitance? Okay, I'm going to repeat myself. For this series circuit, what is the equivalent capacitance? What is the total lah sebenarnya? Equivalent tu total je sebenarnya. So what is the total capacitance of this circuit? So circuit ni ada dua je. So, and it is in series. Okay. So first thing you need to know is if it is in series, or parallel. Second is the equation. Okay. Tak payah ingat step ni pun tak apa, dua je pun. Okay, so basically, okay, this guy is in series, so the equation that I should use is as the following. So 1 over C1 plus 1 over C2 is equal to 1 over C equivalent. So if they ask you what is C equivalent, so you have to, let's say C1 is 5 and C2 is also 5. So if I were to use this equation, C equivalent, 1 over C equivalent is equal to 1 over 5 plus 1 over 5. So 1 over 5 plus 1 over 5 is 2 over 5, which is equal to 1 over C equivalent. So C equivalent is equal to 5 over 2 or 2.5. 5 over 2 or 2.5 farad. Betul, farad. So this is how you use the equation for a circuit in series. And this is a circuit in parallel. Tapi dia flip. Okay, dia flip . So previously we saw the capacitor vertically macam ni. Now you rotate it by 90 degrees. It is the same circuit basically. This is your battery. Okay, this is your capacitor, this is your capacitor. Kita nampak takat ni je. Okay, so if C1 is 3, C2 is 5. How do I calculate for the C equivalent for a parallel circuit? So this is the equation that you should use. So parallel dia tambah aja. So C1 plus C2 is equal to C equivalent. So this is 3 plus 5 is equal to C equivalent, which is equal to 8 farad. Okay, so in series, use this equation. In parallel, you just simply add it together. But the trick here is to understand whether they are in parallel or whether they are in series. So that is where it gets tricky. Equation is senang je. Knowing what circuit it is the confusing part here. Okay, so let's do before that. This is the equation that we need to know. So capacitors in series, I told you V1 plus V2 should be equal to V total. Okay, so this is V total, V1 plus V2. Therefore, the number of charge in each capacitor are equal. I told you the I that they see are the same person. Teruk lah, cheating. But this is a circuit. So if they meet the same I, it means they meet the same Q. So this means that, okay, remember C equals to Q over V. They meet the same person. So if I were to rearrange this to solve for V, this is Q over C. They meet the same person, which is the same Q. Same person ni maksudnya same I, sorry. I should say same I. They meet the same current, which means that they meet the same Q. So if I can rewrite this to be 1 over Q over C equivalent equals to Q over C1 plus Q over C2. Okay, from this equation. Mula kita cakap V total equals to V1 plus V2. And we know the equation for capacitance is C equals to Q over V. For a series circuit, you get the same I. You meet the same current. The same current means you meet the same charges. You meet the same Q. So I substitute V total to be Q over C equivalent, or Q over C total equals to Q over C1 plus Q over C2. Yang berbeza kat sini is your C1, C2 and C equivalent. Okay. From this equation, we get the equation for our C equivalent for a series circuit. Itu je. Okay, so that is for series. For parallel, we know that the V1, V2, V battery is equal. So V1 equals to V2 equals to V total. Okay, so again, C equals to Q over V. If the V are equal, which means that, sorry, V is equal in this case. So V is C over Q. And then I try to substitute into this equation. Let's see this one. So Q total is equals to Q1 plus Q2 because I total equals to I1 plus I2. Oh, dekat sini. We talked about this, right? Saya ada I total and it splits into I1 into I2. Okay, if you guys still remember. So I total equals to I1 plus I2, which is equal to Q total equals to Q1 plus Q2. So you get this equation. So C equivalent V, they are okay. They are substituting for Q. So this is your equation. They are substituting for Q based on this equation. So CV equals to Q. So Q total is C equivalent V. V is the same. So this is Q equivalent. C1V, V is the same. This is Q1. C2V, this is Q2. And then just plug it in. Okay, so they based it off what is not the same. So in this case, for a parallel circuit, your Q is not the same. For your series circuit, your V is not the same. So this is how they derive the equation. Do you have to derive it? No, you don't have to. You just have to remember this equation and the concept of series and parallel. Okay, ingat equation ni je. It's fine. But if you can derive it, that's better because it shows your level of understanding is better. Okay. So moving on, let's do this one. Equivalent capacitance from point A to point B. Dah susah. Previously, we talked about series sahaja and parallel sahaja. What if your circuit has both, right? Okay, so let me talk about this circuit first before we start solving it. So capacitance number, let's label it first. So C1, C2, C3, C4, C5, C6. Okay, so what is the equivalent capacitance between point A to point B? Okay, please focus here. If you are distracted, please come back. So C1 is in parallel with C2. Can anyone tell me why? C1 is in parallel with C2. Why? Can anyone tell me?
They meet at the same point.
Betul, they are connected by the same points. If I have a point called, sorry, let's use different one. If I have a point called D and E, right? So C1 meets E, C1 meets D, C2 also meets E, C2 also meets D. They meet the same 2 points. So I can say capacitor number 1 and capacitor number 2 are parallel to each other. So if they are parallel, I can use the equation C equivalent equals to C1 plus C2. So the C equivalent for this dude over here between this point and this point is equal to 1 plus 3 equals to 4. This is not the C equivalent from A to B. This is the C equivalent for this point only. So let's call this point star and no, susah please. Alpha and beta. No, susah juga. X and Z. So the C equivalent between X and Z is 4. That is your first one. So if I were to redraw this, I can redraw it like this. Let's just say C12, okay? Because this is C1 and this is C2. Okay, so this is your C equivalent called C12. Now you can eliminate this guy, okay? So that was if you had C1 in parallel with C2. Okay, so I'm gonna ask someone else who is my lucky winner. Can I ask Divya? Okay, so C12, is Divya there?
Yes, doctor.
Okay, so C3 and C12, are they in series or are they in parallel?
C3 and C12, they are in series
They are in series. Why?
because they have the same, they are meeting the same current.
Yes, correct. Thank you, Divya. That is correct because they are meeting the same current. So if I flow I over here and it meets C3, the I will flow into C12. So same current. Betul. That is how you determine whether it's in series or not. Okay, so C3 is in series with C12. So my equation should be C equivalent, C 1 over C equivalent, 1 over C, let me rewrite this nicely. 1 over C equivalent equals to 1 over C3 plus 1 over C12. C3 is 4, C12 is 4. So that is 1 over 4 plus 1 over 4 is 2 over 4. So my C equivalent is 2 farad. Okay. Assuming you guys know the units, let's just say it's 2. Okay, so I know that C3 is in series with C12. Now I can redraw this to be, I can redraw this whole thing, right? Redrawing, sex resistor pula, terlangkau chapter. Okay. This to be C123, which is equal to 2. Okay, so tadi we got this part as 4. We got this part, this is 4. So 4 in series with 4 will give me a C equivalent of 2. So this whole top part is just equal to 2. That is your C equivalent for the top part. Okay, C equivalent is just the total. Okay, so moving on to the down part. Okay, I'm gonna ask Redo. Is Redo there? Is Redo there? So Redo is sleeping. Okay. What about Haziq? Amirul Haziq.
Yes, betul.
Okay. So that is Amirul Haziq. Okay. Kenapa muka saya stuck kat sini? Oh, it's not stuck anymore. Okay, so C pula dah. 6 and 2. Are they in series or are they in parallel?
In parallel.
In parallel, why?
They meet at the same point.
They meet the same point. Okay, correct. Thank you. So what is the equation to calculate for parallel, Haziq?
C equivalent equal to C4 plus C5.
Okay, correct. Thank you. So that is equivalent equals
Okay.
C4 plus C5. And it is 6 plus 2, which gives me 8. Okay, so I can redraw this. Okay, suka sangat lukis resistor. So I can redraw this to be C45 equals to 8. And again, C45 is in series with C5. Is it C5? C6. C45 is in series with C6, which means that my equation should be 1 over C45 plus 1 over C6 to get my C equivalent. Okay, so C45 is 1 over 8 plus 1 over 8. So this is 2 over 8. So my C equivalent is 2 over 8. 8 over 2 is 4. So this whole part, this whole down part is C456. Okay, C456. Saya lukis balik tahu yang korang boleh abaikan yang belakang tu. C456 is equal to 4. I hope I'm right. So C123 and C456, are they in parallel or are they in series? Anyone?
Parallel.
Parallel.
Parallel,
Parallel.
right? Because they meet the same points. If this is me over here, this is Nick over here, they meet us both. So C123 meets Nat and Nick. C456 meets Nat and Nick. So we can say they are in parallel. So for parallel, we can just add them together. C equivalent yang paling C equivalent, which is the C total for the whole circuit, is equal to C123 plus C456. Okay? All right, so I think if you understand what parallel is, what is series, this should be okay. This should be easy for you. Tak lah easy, okay lah. Okay, just don't get confused. So what did we get? Sama tak? 6. So we got 2 and 4. Yay, betul. And then 2 plus 4 is 6. Okay, so example. 3 capacitors are connected in series. Oh, we have 5 minutes left. Sempat tak? Tak sempat ni. Okay, let's just do one example. Nanti saya akan continue with next class. So 3 capacitors are connected in series. Calculate the equivalent capacitance if the capacitance of the capacitors are 2, 8 and 12 micro. Okay, senang je pakai equation je. Series 1 C equivalent 1 over 2, 1 over 8 plus 1 over 12. Don't forget the micro. Okay. And then your C equivalent, use your calculator, don't be lazy. So you get 17 over 24. This is 1 over C equivalent, which means that your C equivalent will be 24 over 17. Dia terbalik. Okay, so it's 24 over 17, which is 1.41 microfarad. Use your calculator correctly, insyaAllah dapat jawapan yang betul. Okay, moving on. The circuit below shows an arrangement of capacitors consisting of capacitors C1, C2, and C3. This is your battery. C1 is in series with C2. They meet if I have an I total here, and this is my I1, this is my I2. I1 meets C1 and C2. So C1 and C2 are in series with each other. So I can say, ya, kenapa macam susah pula nak lukis ni? Okay. Let me redraw this. So if I have I total, right? Gemuk sangat pula tulisan dia. Kejap. I total, right? So I total flows, we have a diversion over here, macam simpang 3, macam jalan raya lah. So you have I1, you have I2. I1 goes through 4 microfarad and also through C2, 12 microfarad. So C1 and C2 are in series. C1 and C2 in series. So the equation should be 1 over C equivalent equals to 1 over 4 micro plus 1 over 12 microfarad. And then C, this whatever the value that you get for the C equivalent, can someone calculate that for me? 1 over 4 plus 1 over 12 is, I don't know. Anyone?
3 right there.
3.
C equivalent is 3. So 3
3.
microfarad. So this is the top part, it's 3. So 3 is in parallel with 6 because they meet the same dudes over here on the sides. So this is C12 meets with the same points as C3. So C12 and C3 are parallel. So C equivalent is equal to C1, 2, 3, and 6, which gives you 9 microfarad. Okay, so let's see if we got the answer. So it's asking to find the potential difference across capacitor C2. Okay, tak apa, nanti kita buat yang tu. So we got 9. Yay. So it was 3 for the top part. This was 3. 3 in parallel with 6 gives you 9. So this is, they redrawn the circuit to just have C equivalent. Okay, so the question, ada soalan kedua. Find the potential difference across capacitor C2. Potential difference in this case simply means V. So it's asking what is C2 punya voltage. Okay, so let's take a look at this circuit again. Do we have time? Oh, we have 1 minute left. Let's continue next class. Okay, so does anyone have any questions before we end class? I will continue on this part next Wednesday. If not, then we are done. Okay. Anyone? No questions? So it's easy. Everyone can score. That's good. Okay, so don't forget to sign in your Putra Blast. Sign in your attendance. Otherwise, have a great day. Don't forget to have lunch. Stay safe, and I will see you after week 13. No, I will see you on week 13. So before that, kita akan belajar online je. Okay, take care everyone. Bye-bye.
Thank you.
Thank you, Doctor.
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 Bye. Dia cakap dah Redon ni tidur ni. Jaya and Fakri, are you there? Bye.
Ada. Thank you, Doctor.